Hi everybody, in this lesson on applying radians, we're going to look at the area formula. So you definitely want to put the title and the date and copy down the area formula. Now the book uses this fancy A when it's talking about the area formula. I just simply use a capital letter A. So this is the formula you want to put into your notes. Area equals 1/2 the radius squared times theta, where theta is in radians. And we're finding the area of this sector. A sector is like a piece of pizza or a slice of pie. It's like a section of a circle. So we're going to find the area of the sector. You can see that, like I said, it's like a piece of pie. And we're going to use the area formula. We're going to plug in what we know and then see what else we may need to do to solve this problem. Find the area of the sector. That means we're looking for A. 1/2 is given. We could just bring that down. The radius of this circle is 6. You've got to square the radius. And then you also need the theta. Okay, now this is where I'm going to have a little issue in this example, because I am only allowed to have one unknown piece of information. In this particular example, I have two things that are unknown, but what I do know is I know this length. So we learned a formula last time we met, which gives you S equals R theta. If you know the arc length and the radius, you can then find the angle. Okay, so I would do this first to determine what is missing. Since I'm missing this angle, I can do this formula second, and that will help me find that angle measure. Okay, so I'm going to plug in what I know. I know that the S, the arc length, is just 2 pi. That's that arc length here, 2 pi. The radius of this circle is 6. So if I want to figure out what the angle is, all I need to do here is divide by 6. This 2/6, both of these numbers are divisible by 2. So 2 pi divided by 2 is pi, and 6 divided by 2 is 3. So this would be pi/3 radians, which I can now take and plug in place of this missing angle. Okay, so I'm going to rewrite the formula. A equals, again, we're still looking for the area, 1/2. You can go ahead and multiply this out. 6 squared means 6 times 6, which is 36. And theta, which is what we just found, is pi/3 radians. Remember, in order to use this formula, you always have to enter the angle in radians, which is pi/3. That's definitely radians. Okay, so I can continue to simplify this thing. If I'm taking half of 36, it's like dividing 36 by 2. So 36 divided by 2 is 18. And I still have the pi/3. Now, if it helps you to look at this number, you can go ahead and multiply these together, but the directions for this section want you to leave the pi in the answer. So what I could do, just to kind of visually see what I need to reduce, I can multiply 18 pi, which is 18 pi, and I could divide by 3. Now, hopefully this helps you to see that 18 and 3 are divisible. So you can take the 18 divided by 3, and that will equal 6. If you need to type that into the calculator, it's just simple. You just type in 18 divided by 3 like you normally would, and you see that it equals 6. So you have 6 pi. Since this is an area, you will label this as something square units. So if you look at this example, no labels are given, so we can just say square units, or even simpler, you can just say units squared. If you had like feet or inches or yards, you could say like square inches, square feet. This one we don't know, so we could just say square units. Okay, same type of thing. We're going to use the same formula, but this time we're looking for the central angle. Now the directions say in degrees. When you get the answer of the angle in these formulas, you're going to get the answer in radians. So we're going to have to do one last step at the end. We'll have to turn our radian answer back into degrees. Start with the area formula and plug in what you know. Okay, now this time you're looking for something different. and so different information is given. The area, according to the directions, the number inside the sector is the area. So this number inside this sector is the area. So 6 pi square units goes here. The radius is given, that's 6. And don't forget you have to square it. And then theta is what we're trying to find. Find the angle, that's theta. So let's do some calculations. We're just going to kind of simplify this up here. 6 squared, 6 times 6 is 36. I'm bringing down the times 1/2. And I'm bringing down theta. Okay, the next thing that I'm going to do is find half of 36. Remember, that just means you're dividing 36 by 2, dividing it half, divide by 2, and that equals 18. I'm trying to get the theta by itself, so I'm going to divide both sides by 18. If you have a hard time dividing this, you can use your calculator if needed, but really 6 and 18 both divide evenly by 6. 6 pi divided by 6 is 1 pi, or just pi, and 18 divided by 6 is 3. You could also use the calculator to help you with this if you wanted to. You would just do 6 divided by 18. You'd see that it's 0.3 repeating, which is 1/3 as a fraction. You could hit math, enter, enter, just to kind of confirm your thinking, and it is 1/3, or in this case, pi over 3. Okay, now that is the radian measure. If you wanted the radian measure for this question, you would be finished. But remember, at the top of this, the directions actually said to give that answer in degrees. So we do have to do one more step. That step is what we learned at the beginning of this chapter, how to convert from radians to degrees. So there was a conversion factor that we used. We always said that 180 degrees is equal to pi radians. So if I multiply this whole thing by this conversion factor, I can then change it back into degrees. Okay, so think about what you're trying to get rid of. This is radians, pi over 3. I want to get rid of radians. That means the radian measurement needs to go at the bottom. Pi is the radian measure, that's what goes at the bottom. The 180 degrees is what goes at the top, so your numerator. Cross out what you can, so the pi's divide out, and you're left with 180 divided by 3. Okay, so some of you can do that in your brain, and that would be perfectly fine. If you need to use the calculator, 180 divided by 3 is 60 degrees. Okay, the directions for this question said give theta, give the central angle in degrees, and we saw that it was pi over 3 radians, which equals 60 degrees. So this question is complete. This time we're going to find the central angle, but this time you are finding it in radians. So we're going to use the same formula, and we're going to find the angle, and then we don't have to worry about converting this time. And what I mean by that is, remember in this last one, we took this answer that we got and we had to change it back to degrees. We won't have to do this time because we are being asked to find the radians. So let's plug in what's given. Again, the area, the book says, is the thing inside the shaded region. So this area is 3. We're going to multiply that by the radius squared, which is 2 squared. And then we're going to multiply that by theta. Well, theta is what we're looking for, the central angle. That's the angle theta. So we're good. We only have one piece of unknown information. So let's kind of simplify this thing up. 2 squared. 2 times 2 is 4. And you're finding half of 4. In other words, 4 divided by 2. So all of this, 2 squared is 4. Half of 4 is 2. So this whole thing is 2. We still have the theta. And that still equals 3. Think about how you would get rid of this 2. The 2 and the theta are right next to each other. Remember, that means multiply. So you're going to divide by 2. You could leave it as 3 over 2, but really, Radians are usually written as decimals if there's no pi in it. So you can write it as 1.5. So your choice, you can either leave it as 3 over 2 radians, or you could just put 1.5 radians. Since there's no pi, I don't have to worry about keeping it a fraction. So either way would be perfectly fine. And this one's done. You're just looking for the central angle in radians. We got it. It's 1.5 radians. This is our last example. In this part of the assignment, you're going to find the area of the sector. So again, you're looking for area. And this time you're going to be putting it all into the calculator. The directions will say to round your answer. So when you're rounding your answer, that means you're going to be typing even the pi into the calculator. So since I'm going to be using the calculator, I'm going to change this 1/2 into a decimal as well. If you don't know what 1/2 is as a decimal, think about money. Half of a dollar is 50 cents. So I can say that 1/2 is like 50 cents or just 0.5. I'm going to multiply that times the radius squared. Okay, look at the radius that's given, 59.8 kilometers. So 59.8 squared. Then I'm going to multiply that by theta. Theta is also given in this question. Theta is 2 pi over 3 radians. Okay, notice how it's radians, so we can use it directly. If they gave you the answer in degrees for the angle, you would have to change it first. This one's radians, so we're good. Okay, so let's go ahead and multiply. When I multiply this out, I'm going to multiply everything that would be considered a numerator. So that's going to be 0.5 times 59.8 squared times 2 pi, and I'm going to hit enter in my calculator. Okay, you can see that I typed everything that would be considered numerator. I'm going to hit enter, and then I'm going to divide by 3. So I'm going to hit enter, and then I'm going to divide by 3. Okay, so the directions say to round to the tenths place, so that would be 3,744.8. And in this one, you actually have a label, so you could say square kilometers or kilometers squared. I'm just going to say km squared, just to keep it simple. Okay, so whenever you're talking about area, remember it's always like square units, square inches, square feet, square yards, etc. This is the assignment set for this assignment, and I'm going to help you do question 44. You do not have to copy down the problems. I have it copied just so I can kind of see what the question is. So question 44 gives you this information, and it says find the area of the sector. So this is like the beginning of your examples where we're going to give the exact answers, not a decimal. Okay, so we don't know the area. That's what's unknown. We know 1/2, that's given. The radius is 8. Don't forget to square it. Okay, now here's where we would normally plug in another variable. But again, we have this situation like we got in example A, where we have two things that are unknown. So what we're going to have to do is we're going to have to figure out this theta over on the side. We know the arc length. When we know the S value, the arc length, and we know a radius, then we can find the angle. Okay, so again, start here. This is what you do first. And over here, this is what we're going to do second. We're going to use S equals R theta, and we're going to do that in order to find the angle. Okay, so S is your arc length, 4 pi. The radius is 8. And we're trying to find this angle so that we can plug it into this formula. So in order to get the theta by itself, you need to divide by 8. 4 pi over 8, well, 4 divided by 4 is 1 pi, or pi. 8 divided by 4 is 2. So it reduces to 1/2, or pi over 2. I'm going to take this angle, and I'm plugging it back in place of that theta. So that's going to go right up here, and I'm going to plug it in. Okay, so I'm going to rewrite it. Area equals 1/2. Again, I'm sticking with 1/2 again because I'm not typing all of this into the calculator. 8 squared, 8 times 8, I could do that now. That's 64. And we just found out the theta is pi over 2. Radians, but you don't have to write the word radians. Okay, so let's go ahead and simplify this out. Half of 64 is like taking 64 and dividing it by 2. So 64 divided by 2 is 32. I'm still going to be multiplying that by pi over 2. Okay, multiplying by pi over 2, if you have a hard time visualizing this, you can write it as 32 pi over 2. And if you divide 32 by 2, you will see that that ends up equaling 16 pi. Okay, we want to put some sort of a label. This is area, so you could say square units or units squared, since there's no other label available. Okay, so that will be it for today. Continue working on these problems. Have a great day.